Astronomers detect a possible signature of life on a distant planet, a giant planet. Tassatun 24. Light years from Earth has yielded the strongest evidence yet that extraterrestrial life may be thriving beyond our solar system, astronomers claim. Observations by the James Webb Space Telescope of a planet called K2-18b appear to reveal the chemical fingerprints of two compounds that, on Earth, are only known to be produced by life. Detection of the chemicals dimethyl sulfide, DMS, and dimethyl disulfide, DMDS, would not amount to proof of alien biological activity, but could bring the answer to the question of whether we are alone in the universe much closer. This is the strongest evidence to date for a biological activity beyond the solar system, said Prof. Niku Madhusudan, an astrophysicist at the University of Cambridge who led the observations. We are very cautious. We have to question ourselves both on whether the signal is real and what it means. Others are more skeptical, with questions remaining about whether the overall conditions on K2-18b are favorable to life and whether DMS and DMDS, which are largely produced by marine phytoplankton on Earth, can be reliably regarded as biosignatures. K2-18b, which sits in the Leo constellation, is nearly 9 times as massive as the Earth and 2.6 times as large and orbits in the habitable zone of its star, a cool red dwarf less than half the size of the Sun. When the Hubble Space Telescope appeared to spot water vapor in its atmosphere in 2019, scientists declared it the most habitable known world beyond the solar system. The supposed water signal was shown to be methane in follow-up observations by Madhusudan's team in 2023, but they argued K2-18b's profile was consistent with a habitable world covered in a vast, deep ocean, a view that remains contentious. More provocatively, the Cambridge team reported a tentative hint of DMS. He added, "Decades from now, we may look back at this point in time and recognize it was when the living universe came within reach. This could be the tipping point, where suddenly the fundamental question of whether we're alone in the universe is one we're capable of answering. Planets beyond our solar system are too distant to photograph or reach with robotic spacecraft, but scientists can estimate their size, density, and temperature and probe their chemical makeup by tracking the exoplanet as it passes across the face of its host star and measuring starlight that has been filtered through its atmosphere. In the latest observations, wavelengths that are absorbed by DMS and DMDS were seen to suddenly drop off as K2-18b wandered in front of the red dwarf. The signal came through strong and clear," said Madhusudan. "If we can detect these molecules on habitable planets, this is the first time we've been able to do that as a species. It's mind-boggling that this is possible. A challenge in identifying potential other processes is that the conditions on K2-18b remain disputed. While the Cambridge team favor an ocean scenario, others say the data is suggestive of a gas planet, or one with oceans made of magma, not water. There is a question of whether DMS could have been brought to the planet by comets this would require. An intensity of bombardment that seems improbable or produced in hydrothermal vents, volcanoes, or lightning storms through exotic chemical processes. Life is one of the options, but it's one among many," said Dr. Nora Hani, a chemist at the Physics Institute of the University of Bern, whose research revealed that DMS was present on an icy, lifeless comet. "We would have to strictly rule out all the other options before claiming life." The findings, published in the Astrophysical Journal Letters, suggest concentrations of DMS, DMDS, or both their signatures overlap thousands of times stronger than the levels on Earth. The results are reported with a 3 sigma level of statistical significance, a 0.3% probability that they occurred by chance, although this falls short of the gold standard for discoveries in physics. There may be processes that we don't know about that are producing these molecules, Madhusudan said, but I don't think there is any known process that can explain this without biology. Others say that measuring planetary atmospheres may never yield a smoking gun for life. It's underappreciated in the field, but techno-signatures, such as an intercepted message from an advanced civilization, could be better smoking guns, despite the unlikelihood of finding such a signal, said Dr. Caroline Morley, an astrophysicist at the University of Texas, Austin, adding that the findings were nonetheless an important advance.